In this session, we're going to give you the comprehensive power repair guide and talk about how to accurately judge when it comes to abnormal power electrical problems. Before we're heading to the next session, single converter IC, something you might already notice is that for most IC repair introduction that I just mentioned previously, normally the most is treated as individuals. However, in this case, most will be combined into the converter. In other words, that simply means high gate and low gate is no longer show up in circuit diagram, but integrated into converters instead. There are two conversions. One is the conversions from low voltage to low voltage. The other is from high voltage to low voltage. When it comes to high and low, we have to know what range of voltage defines if it's high or low. Well, the value of voltage that is under 6 volts calls low voltage, while over than 16 volts is high voltage. RT576A and UP9021 are examples of conversions from low to low voltage. As you can see here, PV-in is V-in. SV-in means VCC or VDD, while enable pin indicates pin 5. Take conversion from 3.3 volt to 2.5 volt, for example. Confirm if IC works and VDD got 3.3 volt. If not, then 3VA DSW given from system IC might be the reason that causes abnormality. As you can see here, there is no MOS, but only IC, capacitor, inductor, and output. That is to say, it can be the problem that caused by converter once input and enable pin are working except output. For further repair details about single converter IC, please refer to these instructions step by step. The other example is HPA02240, and it's the conversion from high to low voltage. So please note that there is an extra LDO code V reference, which is pin 26, and it needs to check out as well. Let's take 1.05 VUSAs for example. The impedance of V-in, V5 which is VCC, V reference, and enable got to be over than 100 ohm. V5 will send the signal to generate V reference output. So once this V reference output is detecting, that means IC is working without any problem found. And since V-in connects to AC battery system, and V5 connects to 5 VUSAs, so if something wrong measured, then better confirm if the abnormality happens on charger IC or system IC. Move on to stage 7. Enable pin couldn't work until EC delivered the signal to it. So basically we could say that enable pin and EC go hand in hand. Therefore, once EC is found abnormal, please go to check LX or code SW. Over here, SW. As the direction of current flow starts from LX through inductor capacity until output conversion. So if something wrong with LX, check if it's converter's problem. The pin mark-in rate is the one that you should focus on this V-core IC. Among this pin, PVCC is the control voltage of MOS, which MOS is converted from 5 volts. So normally VCC and PVCC are supposed to have the voltage of 5 volts as well. VRAMP is to detect the signal from AC battery. When every part that we just mentioned is ready, it will trigger the power good called VR ready. Let's take a look at this sequence on the left hand side. In the beginning, VCC got the power, followed by enable. After that, an output is turned on and therefore follow it with power good. As you can see on the right hand side table, here is a request of power sequence from Intel. When power boots up, VCC SA will be the only one that gets power. As for VCore and VCC GT, they won't get any power in the first place. According to this sequence figure, enable initiate VCC SA to have the power, then followed by VReady. After the power for the first three is ready, then let's take a look at the rest of them. SVID won't be enabled until platform reset is working, and bring VCC and VCC GT in the end of the sequence. However, some engineers might misjudge the case and consider CPU a device that caused something wrong when checking VCC SA with correct voltage but found no any output on VCore and VCC GT. The general reason that caused abnormality is because Southbridge didn't send the signal to platform reset. And because of that, VCC and VCC GT are not able to receive the signal from platform reset to make CPU work. So the check-in order should be VCC SA first, then after a signal of V reset are given out from Southbridge, VCC and VCC GT could be enabled. Let's start from impedance checking procedure, as usual. See if the impedance of VRAMP, VCC, PVCC, and enable are over than 100 ohm. And then what's next is the voltage measurement for VRAMP, VCC, PVCC, and enable, to see if they are in normal value of voltage. After that, measure the voltage of VReady and VCC SA to see if they are in normal value of voltage. If not, please confirm if VCore IC has some problem with it. For step 9, measure the voltage for VReady and platform reset. If the value of voltage is abnormal, please confirm if VCore IC has a problem or the device of CPU has something wrong with it. That's all for the entire power repair instructions. Thank you for listening.